Hello, my hosts, and welcome to a coding stream. Today we are working on our project Tween, which is going to be a animation programming type thing. So let's go to the main website or whatever. Let's see if we can go F11. Cool. So I'll go full page. Let's talk about this. So, let's talk about what I want from the things. So we're working on a specification. Go like that. Let's Control-Shift-1. How do I... there we go. There we go. Okay. So I'm going to start off with a story. It's it. And I'm going to go to stories. As a content creator, I want an animation program that is stable. Actually, I don't want even that. Let's put in the cart before horse. I want to be able to create animations. So that I can create animated content for my videos. As a creator, I want it to be vector based so that I can scale everything arbitrarily and because I like the look of vector graphic. As a content creator, I want it to be fast and stable because all the competing products are not, but everyone wants stable software, so why is this even a thing? Okay. As content creator, I want it to be node based because I find node based interactions a lot easier. Okay. A content creator, I want to be able to have an audio track for reference because I debate to the audio track as a reader. I want to be able to animate to the screen for fast so fast sort of turnaround times. Turnaround times. Say content creator. I want to be able to animate to a directory of files that are numbered so I can animate. I can what's the word for it? Import this into Resolve. Ideas slash so this section here is just me thinking up ideas before we go into a formal spec. So specification. Okay. Okay. Central concept is going to be around population. Create 2D animation. That's important. Math. Consider that mathematically okay. A 2D animation is a 3D object where we are moving through slices of it. Does that allow for optimizations, etc.? All right. Because what we can do is if we think of these as sort of planes, we might be able to make use of that. Okay. So we will start off in an space that ranges from 0 to 1 in X, Y, and Z. Actually, W. Actually, we'll call the time dimension T. Where T is the time dimension. Since the we render, we convert the 0 to 1 to a frame space in pixels and frames. So but we will often need to extend beyond the initial range, though 0 to 1 will be default. This is so we will have to the ability to pin keyframes to a frame at a particular FPS and duration, because that's how animators think. Although the product is going to be mostly for us, so we can be sort of peculiar. Okay. Treat everything as an abstract color space as well, with RGB values between 0 and 1. This means that code for vectors will also work for vectors will also work with RGB. That's convenient. So now I'm Archive Smartens. So, all right. Rendering pipeline. How's that going to work? How are you doing, by the way? So we start off with scene. Congratulations. This one's going to be a little bit different to my other ones. It's rather than gameplay or doing making rendering, I am designing a animation program. And basically this is me getting my ideas my ideas into a concrete form, which the way you do writing out your ideas helps make them more solid. And I am doing quite well. So I'm just going to say scene. And a scene is a single animated sequence, a 3D structure where one of the dimensions is time. Each frame is a slice of a scene in time. We represent a scene using our scene structure. Okay. Let's get some tables. So I'll add the tables here. I always love doing tables for data structures. It seems to work right. Now, tools, format, text. Where is table? How do we add? Oh, we're in normal text. Insert image, insert comment. Why have I suddenly lost? Oh, insert table. Table template. I want 4 of these. Okay. So the heading's going to be name, type, constraints, and events. So for our scene, things that are going to be useful information for the scene, it's going to be the camera. That's going to be of a camera type. We don't know what that is, but it's going to have information about the camera. There we go. This be null. I'm wondering if cameras are compulsory. Make it more complex if it isn't, so we're going to have it, probably have to enforce it, define it will have a default camera. Comments. Don't need any real comments for that at the moment. Okay. Next, we're going to have a these are more a part of the design. the stories are up here. So basically, stories take a templated structure, which is, as a person, I want something so that I can something. And then we haven't really gotten to a specification yet, because specification is sort of like a more formal step. So here I'm just brainstorming, noting down ideas as they come into my head, and then we'll sort of organize those. And as I write down ideas, that stimulates further ideas in my head, and I can start to see things where those things will conflict, and then we can go and make revisions. Okay. Now, at the sort of scene level, we're going to have a shape tree. I'm thinking. Okay. I'll have to rename this maybe. We'll represent the scene as a collection of shapes and operations on those between those shapes. All right, I think we're going to have to... Actually, what we're going to call this section actually here, this is going to be our glossary slash... So each concept is going to have sort of like a name to it, so when we use those words later on, we know what we're talking about. So a shape is a thing that exists in 3D time space, representing... If you want help with stories or something, I can help. I like to think I'm decent at thinking of stories. When I say stories here, I'm talking about stories in the programming sense rather than the narrative sense. Basically, the idea of stories is to create a way that to communicate how people... It's a formal way to communicate how people will be expecting you to do something, basically. It's sort of like a formal... a templated way to show requirements to stop people there is a tendency for programmers to think about what they can implement rather than what is needed to be done, and stories is a way to stop programmers from doing that, basically. Shape is a thing that exists in 3D time space. It has an inside and an outside and a boundary between the two. The shapes inside inside has a color? No, it doesn't have a color. The shapes inside, because we want to be able to do gradients in colors as well. That's the thing. As a content creator, I want to be able to have the things that I animate have colors that change over space and time, because that looks good. There we go. So the space side of a space time inside of a shape has a specific color behavior, I guess. We need a better name for that. I'm going to tell us. Oh, I got it. This is going to sound strange, but I think it's the best way to do it. It's a specific biome. I know it's weird, but I'm just going to close my door. Specific biome. And I'm going to change you to 4. So I'm going to definitely define a biome. A biome is a mapping between 3D space time and color space. That's really abstract, but I will sort of expand that. It means that at any point within a biome, you can work out what color it should be. Colors can change over space and time. This allows us to make gradients that change color and complex complex patterns. The thing is, now that I think about it, everything is basically a biome. but I think it makes sense to make a distinction between... I think it allows us to give optimizations if we have the shapes as a separate concept to the variations within a biome. Okay. Space-time within it has a specific biome. Shapes can be operated upon with Boolean parameters such as okay, intersections. Intersection. Union. And fronts. Diff. Okay. That is handy as well. Each frame diff and also section union diff. And converse. I think it's converse. So either way, it's the one that takes the invert. Inverse. In here, we... Sorry to go, but good luck. Thanks. We can implement all the operators as by first implementing arrow. It doesn't. No, it doesn't replace. Does that replace? Nope. What a pity. Arrow and verse. This will be a first operation implementation. Then we can demise. Okay. Between those shapes. Yeah. And this can be nullable. All right. Shapes exist in 3D time space, has an inside and out boundary between the two. Space time. Okay. Boom. Oh. Right. Actually, that... So, a func... is a function of the form so this is for a struct. To tools. Language page setup. Find and replace, view, insert special. How do I just do that naturally? I do not know. All right. Hide that. Type. Is space-time to bold space-time to color space. Actually. Okay. We continue here. Let's define ourselves a color space. The space is an realization of RGBA, where all the values are between 0 and 1, where 0 is off and 1 is on. We then smash this down into whatever bit depth is required. Okay. That implies we're going to need something that sits on top of the scene, which contains, as well as the scene, sort of like the practical information. Right. does that exist inside the camera? Like bit depth. And pixels. That sort of makes sense. Like the camera is recording the world. So it makes sense that the camera is the thing that sort of translates things. Okay. Let's do that. The camera is the thing that governs how the world of the scene gets translated to real life. It both the all right, let's insert our thing here. Some of these menu items are hard to insert. Table. Okay, so how do we change this to headings? Pin header row. Okay. Table properties. Right. Row. Thing pin header row. With color. That looks better. And these all should be bold. Right. Copy this. Let's see if we can just copy this down to there. Cool. Oh, remove you. Delete row. Okay. So the camera. That's FPS. That's going to be in type. No, you can have fractional SPS, so it's going to be a float. There. How's it going? It's going pretty well. And also going to be a float. Comments in seconds in FP in frames per... In hertz? No, in frames per second. Yeah. Slash hertz, because it's they're the same value in a what's the thing? Okay. And color, sorry, bit depth. This is definitely going to be an integer. Constraints. Non negative. Doesn't make sense to have a negative bits depth. It's going to be non-negative as well. Right. Okay. I'm going to put, actually, this is going to be num of 8, 16, 32, 64. We'll say ignore this for an XR. And we're going to have a we can move the camera around inside of the scene space. So we're going to restrain it to being rectangular, and it's going to have to retain its aspect ratio, but it can get bigger and smaller. So I'm going to say have a location value, which is going to be it's going to be a path through space-time. I'm just going to call it a path at the moment. D. I'm going to have to define what that is at some point. That one's definitely going to have to be non-nullable. Location and a size. And it's 2D. Non-nullable. So you can get bigger and smaller, but you can't. That right. Should I call it a path 3D or a curve 3D? Because they're all... Okay, we've got to call it a curve 3D. All right. Depth is required. Okay. So type biome. It's from space time to color space. Match it down whatever bit depth required. We define the bit depth in the camera. Okay, so the number of frames is going to be a product of the SPS and the duration. That's fine. It's sort of like a derived value. Has a specific biome. Shapes can be operated with Boolean operators, blah, blah, blah. And, right. Shape tree is a tree of shapes operated upon by operators. Right, let's copy. So can be it's going to be a tagged. It's going to be an enumeration. So we'll put in another insert here to insert the enumeration. So they're going to be a shape. Remove this column. Delete column. So it's going to be a shape or an operation. All right. And we can remove that. Right. And the operation is going to contain contain subtrees underneath it, depending on what shape it is. Okay. So shapes can be operated such as intersection Boolean. Inverse. So we can define some of the properties shapes have now. It's going to be okay, so each shape has a biome. And a biome and a boundary. Let's delete these things we don't need anymore. delete. No, I want to delete those rows. Delete rows. Delete 3 rows. All right. So that's the type. Biome. And this is a type. Boundary. We'll remove any comments for the second. All right. But we don't even have boundaries at this really abstract level. So at this really abstract level, because we'll have different types of shape, what do we have? I would like to use the word type, but that's a little things. I'm going to say species. That's going to be num of the various species that we support. This is an enumerated type containing the species we support. In the pipeline, all of these will be converted to a consistent rasterization in order to do stuff. Consistent rasterization in order to in order to render. I'm talking around in circles, but we'll clear that. Biome is any function of the form space time to color space. We can make trees of this. Why are we in heading 4 mode? We shouldn't be in heading 4 mode. We should be in normal text mode. And that has EDS between these functions. A tree of it. I think this might be our first sub-project and might make for a good minimal viable product. We can use it to create some funky effect. Cool. Depth is required. Shapes. Species, space tree, shape and operation. Scene, shape tree. Okay. All right, let's go for our operations. Don't want tab properties at the moment. And operation takes 2 ape trees and combines them all to some rule. The shapes underneath and combines the shapes underneath and defines how the and bases interact. It takes 2 space times and combines them. Right, that makes sense. Probably best to have examples. So that's 4, 5. Intersect. B. The inside of A intersect B. Actually, gonna go. Let's go even simpler. If A minus B the inside is the inside of A where that is not inside of B. All right. complement A is all time space that is not inside of A. The inside of complement A is all time space that is not inside of A. That is not inside of B. Let's check our Boolean rule. Complete operators. All right. Or not. That should sect of A and B, the inside side of A that is also inside of B. Now, I think A minus B and complement A is a full thing. So can we union A and sect A union AB, the inside of A along with the inside B. Now, can we implement these? So, minus B and B minus A, that gives us actually we go, hold on, complement A minus complement B, what does that give us? It would help to have some sort of visualization tool for this to do the logic. Oh, no. I can just do the insert table. That's true, false, false, true. And difference is all right. Insert table. Okay, this one's A. This one's B. This one's A minus B. So T, T, F, T, F, T, F, T, F, 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 F. Ah, that's good. That is implies. No, that's false implies. That's not, that is not implies. Cool. Why am I basing it on that when I could just do NAND? We did that because we were trying to plonk everything down into an arrow. But if I'm not even doing Haskell, why would I want to do an arrow? Because I haven't even decided on a language yet. All right. AA there. So what would be A minus B? All right. I wish there was some sort of... Well, there is, isn't there? All right. Oh. We will bother with that a little bit later. Okay, what? Shape trees, camera, shape trees, blah, blah, blah. Type transformers. Can get rid of that now. So we don't even have to go to scene to 3D quads to raster. Okay. All right. And going to find space time as well. Time is a 3D structure with X, Y, and T. I'm thinking now I take a break for lunch and we'll continue on this little project later on. So I've got some editing to do as well. So let's get back to my main room. Thank you, everybody, for joining me in this project. I know it's a little bit strange to do sort of program design as a live stream, but I hope people found it interesting. Tomorrow we'll do something far more orthodox. What shall we do? Yep, tomorrow we'll be playing Factorio. So I hope you can join me for that. Thank you, everybody, for keeping me company as I worked on this. I hope to see you later, and if it's your first time watching, please subscribe. Thank you very much, and goodbye.